So, hi, my name is Camille Ratliff, and I'm going to share my findings on the effect of climate on influenza-like illnesses in Istanbul, Turkey. So, just starting with the background, previous studies suggest that temperature, humidity, pollution, and other socio-demographic factors play a determining role in influenza virus transmission. And Shaman and Cohn showed in a 2009 animal model that absolute humidity may be one of the most potent descriptors. So our question is, in a clinical context, will we be able to see effect of climate on influenza-like illness admissions? So this observational study included ILI, influenza-like illness, patients who were admitted to the emergency department of the American Hospital in Istanbul, Turkey, over an 11-week period in early 2011. Clinical data about patients was collected respectively by structured survey form. Meteorological data concerning temperature, humidity, and pollution was collected from the Turkish State Meteorological Service local stations. So it included over 1,200 patients. You can see descriptors of our patient population here. What I'd really like to focus on is this graph here. Brown is influenza cases over time, or ILI cases over time. Green is temperature in Celsius, and red is absolute humidity in millibars pressure, water vapor pressure. And additionally, you may notice a 7-day period here. Those are Sundays, so we took that temporal information into account. This is also a 2-week vacation period in Turkey, which we also included in our model. So these are simple bivariate linear regressions on each of these variables against ILI cases each day. In just the simple bivariate linear regression, we see significant relationships for absolute humidity, Sundays, and holidays. When we constructed the multivariate model, linear regression, we use temperature, absolute humidity, Sunday, and holidays, and we see a marked effect, in fact, a stronger effect of absolute humidity, and Sundays and holidays still remain strong, as well as mean temperature in determining ILI cases. So by 1 unit increase in absolute humidity, we see a 10-fold increase in ILI cases. By 1 unit increase in mean temperature, a 2-fold decrease in ILI cases. And additionally, on Sundays, 5-fold more patients were admitted for ILI. We also constructed, looking at the predictive power of absolute humidity on daily ILI cases, we constructed an ROC curve using the cutoff value of 2.5 millibars for absolute humidity, and 65% of the cases fell under the curve, which shows that it has some relevant predictive quality. This may have policy implications for hospitals in terms of influenza preparedness. If the absolute humidity were to fall above this 2.5 millibar value on a given day, it made signals for hospitals to expect an increase in ILI cases. Additional work for this study, I'd like to see longer longitudinal data, larger data, a larger patient line, and then additionally it would be interesting to compare a city that has a different climate profile, such as, for example, Ankara, Turkey is much drier than Istanbul, which is on the coast.